Hey, so today we're going to be talking about servo motors. This is a servo motor right here. It's a Futaba S3003. So this is just one of the many types and brands of servo motors. The kind of servo motor that is probably most common that we're going to use in our class, it just has 3 wires coming out of it. And they're made usually to run on 5 volts DC. So you've got a red and a black wire, which is the power. So red is the plus 5 volts, black is ground, and then there's a white wire. And the white wire, it actually is a control line, and that line tells the servo which position to turn to. So you can see servos have a little toothed post that comes out, and you can attach things. This is actually a wheel, but you can get different attachments, and it kind of fits on that toothed wheel. And then when the servo turns, this wheel turns. And most servos that we're going to use, they can't turn all the way around. So see, it can go from about this position to about there. So that's about, I guess, a little bit more than 180 degrees, but not much more, almost exactly 180 degrees. Some servos can do a complete rotation, but most servos are just made to do a partial rotation. And a lot of times, this might be hooked to a lever that positions something like a throttle valve. And for a lot of applications, you don't need it to do a complete rotation. Now, I mentioned that there's a control line, and this control line is how you set the position of the servo. Well, you might be wondering, what do you put on the control line if I want to set the position to, say, 90 degrees. If this is 0 degrees, and this is 90, and this is 180. If I want to move it to a certain position, what do you send to the servo to make it do that? And the way that servos work is you send in a train of pulses. So if you look at these pulses, this is time going this way, and this repeats at 50 hertz. So every 50th of a second, there's a pulse. And the width of the pulse can vary between 1 millisecond and 2 milliseconds. So because it repeats 50 times a second, that means that there's 20 milliseconds total from the start of one pulse to the start of the next pulse. And the pulse can be on for either between 1 or 2 milliseconds. So it's off most of the time. And anywhere in between sets it to a position in between 0 and 180. So if you want to set it to 90 degrees, you put at a 1.5 millisecond pulse width. And I can kind of change this servo to match this a little bit better. I'll move this wheel. That's kind of close. So see, there's 180, and then over here would be 0, and then 90 would be in the middle somewhere. And the nice thing about servos is this is all you have to send in, and this is really easy to make with a microcontroller. You have to be able to have something powerful enough to supply the 5 volts. So you need to have a 5-volt power supply, but the control signal, it doesn't use very much current at all. And a lot of times if you have a microcontroller like our Feather board, the pins can't put out a lot of current, just maybe 10 milliamps or 20 milliamps. So the fact that you can drive this control pin with a microcontroller pin directly is really nice, because you don't need we're not even going to use the motor driver board to drive this stepper. All you need is a source of 5-volt power and then a digital pin that you can toggle off and on 50 times a second. So let's go ahead and we can actually try to drive this servo. I'm using the Feather M0 Express, that has a little proto board here. So your board might have a slightly different pinout. And these microcontrollers actually run on 3.3 volts instead of 5 volts. So the servo needs 5 volts, not 3.3 to power it. But the control signal is actually okay if instead of going from 0 to 5 volts, you're putting in 0 to 3.3. It still recognizes the pulses and it will still work fine. So what we can do is we need to first connect the power. So I've got some jumpers. I'm just going to do this quickly. I'm going to connect the ground to this blue wire, and then I'm going to connect it to the pin on my Feather that says ground right here. And we need now to connect up the 5-volt power supply, the red line coming in here. So I'm going to put this jumper in, and the pin that I'm going to get the 5 volts from is, on my board, it's called USB. And so when you plug up the USB port to your computer, there's 5 volts coming in over the USB port to power it. And this connects directly to that 5-volt line right there. So I'm going to plug it in. You can see the servo actually moved a little bit when I just plugged it in. It goes to some default position, I guess. Let's see. Try that again. Actually, it just kind of moves a little bit when you start it for some reason. And the last thing I need to connect up now is the control signal. And that needs to go to a digital pin that you can toggle quickly. And on this board, the only pins that you can use, there's only a few special pins that can make this kind of a signal, this pulse width modulated signal, or PWM. And one of them is called A2, and that's right here. And you can use different pins, but in my example code, in Adafruit's example code, I'm using A2. So I'm going to plug that up. And you can see the code is already running. And what the code is doing is stepping from 0 to 180 degrees in increments of 10 degrees. So, and then once it gets to 180, it should go back to 0. Let's see if it does that. Yeah, it kind of does it. So I'm going to hook up, I have this little oscilloscope probe right here. I'm going to actually connect that to the control signal so that you can see what's going on. So I'm going to hook up the ground of the oscilloscope, and then I'm going to probe this signal. And you can see over here on the computer screen, there's a train of pulses coming out, and it goes from 0 to 3.3 volts. Let me zoom out a little bit so you can see more than one pulse. There you go. So you can see every, let's see if I can drag a cursor out. So it's every 50th of a second you've got a pulse. So the time between these two pulses is 20 milliseconds right here. So that's 1 over that is 50. So 1 divided by 0.02 is 50. So it's 50 hertz. And then the width of the pulses is changing between 1 and 2 milliseconds. So right now, this cursor, these are 1.6 milliseconds apart. Let me zoom in again, and you can see now just one pulse, and you can see how it's changing from the cursors right now are at 2 milliseconds. and it went a little bit above 2 milliseconds. I don't know why. There's a little bit of an error, and now it should go down to 1 millisecond. Let's see if it does that. It should go right to. Yeah, that was pretty close. It went a little bit smaller than 1 millisecond, but. And over here you can see the code that's generating that. So this is just some example code I got from Adafruit. You have to set up a PWM out object, and I'm doing that on pin A2. Remember I said I had to plug in my control line to pin A2. That's why, because I'm setting it up that way in the code. So I'm making a PWM out object, and I'm specifying it's on pin A2, and then it has a frequency of 50 hertz. And again, that 50 hertz comes from the fact that that's just what servos expect. They need their pulses to be 20 milliseconds apart. Then after that, you use this. Oh, and again, PWM stands for pulse width modulation, and that's a very big word. But what it is saying is you're changing the width of pulses. It's pretty simple actually. So this code is pulse width modulated because the pulses they're coming at a fixed frequency, but the width of them is changing. Like the spacing between them is the same, but their width is changing. So once we've made that PWM object, we make a my servo object. So the my servo object lets you actually say, hey, go to this angle. It's kind of a nicer interface. You probably could just directly write the PWM. So you could say, hey, set the PWM to 2 microseconds or 2 milliseconds or 1.5 milliseconds. But this is just a little bit easier to use. And then right here, we've got the beginning of a loop. So this is a while loop. And because it says while true, it's just going to go through this forever. As long as it has power. Once it gets to here, it's just going to start going around and around. And then inside of this loop, there's 2 smaller loops. So the first loop is taking this variable angle and it's stepping it from 0 to 180 in 10 degree steps. Here it says 5 degrees at a time. That's because I changed it, but it's actually 10 degrees at a time. And all it's doing is saying my servo.angle equals angle. So when angle starts out, it's going to be at 0. And so it's going to say my servo.angle equals 0. And the servo is going to move to 0 degrees. Then the next time around, it will be 10. So it's going to set the servo angle to 10 degrees. And as soon as you set my servo.angle to some number of degrees, the servo is going to immediately move to that, and it's going to change the pulse width out will immediately change. And after each step, I'm just having it wait for a second. So this time.sleep just means wait a second. I could make this a lot smaller if we wanted it to step through them faster. So I can go ahead and do that. And the nice thing with CircuitPython is all you have to do is click save. And see how much faster all of a sudden it's stepping through. And if I want to, I can change the step size. I could change it to and change it to 1 degree steps, so that would be a little bit finer control. So it's moving, but it's very slow now because it's taking 1 degree steps. And then this is the same thing as this. It's just doing it in the opposite direction. So once it gets to 180 degrees, then this moves it back down to 0 degrees. So it just goes all the way clockwise and then all the way back counterclockwise.